About to present the how they are testing on using Docker and mesos in Windows at Windows. Good luck.
Nice to meet you all. My name is Yowie Docker and Testing. I'm from Windows company. If you want details about Windows, you can ask Milan, who's sitting here. And I will present you how we're using Docker and Yowie to do automatic tests. Actually, I have no slides, so if you're waiting for slides, so you can leave. And I have just a couple of points and some demo for you. So, first of all, Yowie, it's our framework built for mesos. Do you know all mesos framework? Not all, okay. So mesos is just an abstraction over real hardware. So let's say you have 3 nodes for your Docker stack, and you have a master and 3 mesos slaves. On each node there is 1 slave. So these slaves are just gathering information about hardware, available CPUs, memory, and disks, and ports, and so on, and sending it back to master. And master just announcing what is available and what is not available. You can ask mesos to just run some task and kill task and get some information. So Yowie, its mesos framework communicates directly with the mesos master. And it's able to use the master to run tasks and kill tasks and gather information. If you know the Marathon framework, for instance, then you will be familiar with the REST API we have. So you can use REST calls to just create tasks, kill tasks, get information about tasks, and so on. We have also web UI, as you will see, working in a minute, and that's just implemented for see what's going on and kill the tasks and so on. You will see. So let me start my own mesos stack and Docker stack. Let's try if I kill it. Yes. So I need to start in my Docker mesos stack, means zookeeper, a mesos master, a mesos slave, and also our framework Yowie. So let's start it. As you can see that I've started the zookeeper, mesos master, mesos slave. This is actually needed for the mesos to be working, and I've started our framework Yowie. So let's take a look. If you go to the refresh this page as well. If you go to the mesos web UI, then you can see that we have 1 slave activated. We have available 2 CPUs and GigaMem. This is actually why, because I've run the Docker in my virtual machine, because as you know, OS X doesn't support Docker natively, so I've created virtual machine. And, I have not enough CPUs and memory to just share, so just a little. And we can take a look that Yowie already knows that there are 2 CPUs, GigaMem, and some ports available, also some attributes. So we have no tasks so far. So take a look on the performance tests. I will answer the question why we actually built new framework, Yowie, because there are a couple of frameworks available like Marathon, Chronos, and many others. However, we found out that they are not suitable our needs, and the needs are. If you run performance tests, you have to have tests repeatable. That actually means that you need data in expected state. For testing integration, acceptance, performance, you need to have data in a state you expect to be actually able to to test it. So let's say for a minute that we have some services like a database. We need to fill the database with some data, and then we have application and let's say some tester. It might be g9k or anything else. To make us familiar with the Yowie, it's like that you just need to send post requests to some /groups endpoint, just some headers, like we expect JSON as sending JSON. And here you can see a group which has some name, DB, and has one task in there. If you know Marathon, you can specify, let's say, the same things. So some name for the task, how many CPUs you need. This is just some number. It's not like that you have available half of CPU, but it's some kind of telling to mesos that you expect load about half a CPU. So if you use all the CPUs and you just decided you need only 0.1 and you will start a lot of services, it will be overloaded. So you need to choose a correct number. And also we need some memory. This is the Docker container we want to run, and some network settings. These environment variables are just for the MySQL. I'm using here the regular Docker image from official repo, MySQL. However, I just made some changes because of this demo. So I wanted to show something. So I made some changes. So let's run it. As you can see, that Yowie returned 201 created, and here you can see some details like ID of the group and ID of the task, and some more details which are not important right now. So here you can see that Yowie already started the MySQL. It should be up and running in like 20 seconds, depending on my hardware. so let's see, and it become ready. So right now we have available service, but we don't have data. I've prepared another container which is able to just load data. To see what's going on is running just this SQL, just to make you familiar. It's just creating database, current everything to one user, create table, and from my DVD CSV just load data into the table. So any magic is just run this container and load data. I send it to the Yowie, and Yowie is running this data loader here and creating DB, and it should be done like in a while. Yeah. So let's wait a moment. Yeah. So we can see that it took 19 seconds to finish. So right now we are able to run the container, and we are able to prepare the containers with some expected state. So that's perfect. That's done. We need services to be available just for testing. Well, in case of performance testing, it's a really crucial thing, because once you have a database which is shared across some services and some other dev services running and just querying the database, then you will have results of the performance tests which are not comparable. So you have to be sure that you have services just for you. As you can see, we are able to just start the Docker containers, and we are done. We are also able to just run it, stop it, and run it again. So if I want to stop it, it's just this icon, or I can use the REST call. That's done as well. Most crucial part for performance tests is this part, regularly controlled. What it means, let's say that I will start all the services I need in parallel. Let's take a look what we have here. It's just the MySQL container in here. Second is the data loader I've run before. You've seen it, just loading data into a database. Third container is the application which will be under test. And the fourth container here is the tester itself. It might be JMeter. I have just only shell script which performs some queries to the application. So if I run these tasks in parallel, let's see what happened. You can see that it just starts running, and it should start running also the other containers as well in a while. You can see that, yeah, it just crashed faster than I expected. So let's take a look. And the movie tester just finished with error. If you want to see what happened actually, or can someone guess what happened, why it crashed?
The database didn't start from float.
Actually, yeah, it was being started in parallel, so we can expect that it will work. Just to make sure, let's take a look on error, and yeah, empty reply from server, whatever it is. Just there is no application, no database, nothing. We just started too fast. So we need to be able to start services in some specified order. We need to run the database first, then we need to load data in there, then we need to start the application, and then we need to start the tests. And it's not like Chronos does, because Chronos can handle such a flow, but actually in the way that it will just wait after the container finishes and then start another one. That's not enough. We need to wait when the database becomes ready, when the data are loaded, so the second container will finish. Then we need to wait when the applications become ready, so it's started running and ready to just process the requests, and then we need to start the tests. And usually you can find some other examples in your company as well, I think. So let's take a look how we can do it. Here I have the same 4 containers. However, I have added some more things. Take a look here. This is the movie data loader, where we think that when the task called MySQL becomes in state ready, then run this task. The same thing is for movie finder. When the movie data loader finishes, start the application, and for the tester, when the movie finder, the application become ready, start the tests. Yeah. So let's run it. Yeah, it accepted the request. Take a look here. Now you can see that it behaves like we expect. It's waiting for the database to just become ready. And once it become ready and started the movie data loader, in a while it finishes, and now application is starting. It will take like 14-15 seconds, and then the tester should run. 57, it should be. Yep. So it become ready, and yeah, it's running tests. However, we have issue here because as you can see in a mesos page, we have 2 containers which are still running, right? So these are the database and the application, which is not bad actually. But when we do the testing, we need to just run tests, and just kill it everything and run it again. So it's not sufficient for us. I will kill it. As you can see that if you kill one task in group, the whole group will be killed. So you can do it manually, but it's not what we're looking for. So yes, we are able to run it in a specified order. However, we need to stop the other services when the finishes. When the test finishes. So yeah, you can specify in group the terminate task. It means that when this task with this name reaches this status, then it will kill the whole group. So you can specify any state of any task, but it should make sense. No. I like it, but I don't want to pay for it. So. Sorry, guys.
It's recorded.
Yeah, that's perfectly okay. They should provide open source. So let's see. Database is ready. Data are loaded. Application is starting Java application, so it will take some time. 40 seconds, and yeah, just wait for it. Actually, it will kill all the running containers once the movie tester finishes. Running, and it should be done in a while. Yes. So it's perfectly okay. We can take a look here. So this task end up in finished state. So it just finished itself, does something, and then finish itself. The same thing for the movie tester. It just run, tested, and finished. However, there is a difference for the MySQL and the application. You can see here these two tasks was killed by the framework because framework just recognized that they are not needed anymore. We have one more thing, which is like, yeah. You can take the blue or anything else. You can play with it. However, more you can see how actually did you set up the dependency. So it's handy actually because my colleague just tried to kill me and just set up a group of 44 containers with some dependencies and some tree in there, crazy stuff. So it's good to take a look. What did you do? So yes, we are able to do this. Next thing is we need to run these services on specified machines. Can anyone guess why it is important? Why we should just do this?
Need different kind of resources.
You are not allowed to ask. Oh. Yes. Yes. Or I can show you. Yeah. Actually, when this stack is only one slave, but in real life you have like 3, 4, 10 servers, and each server has different memory size, disk, different disks, RPMs, SSDs. You have different CPU clocks, you have different memory speed, and so on. So if you would start the service, let's say database, every time on different machine, how you can even compare the results? The results might be different, and you don't know what was the originator of the change. If was it the hardware or was it the software? You have made something or what? So you need to ensure that you are running this task on the same machine all the time. This is fortunately available. You can specify constraints. This is, you can see a list of some object. It has always the name and value, and this actually pointing you to the mesoslave attributes. You can set on each mesoslave attributes. It might be anything. let's actually treat it like a tax, nothing less. So you can there, like I did, type test, or you can, let's say, type database, type application, type tester, or anything you want. And you can specify any number of constraints you need. The relation between many constraints is end. Yeah. So if you run this, do you want to run this demo with the constraint, or you believe me, it works? You believe me? You shouldn't. I talk about testing. It works, hopefully. Yeah, the database was set up, the MySQL was set up with the constraint type and test, and it's actually working. I should run another test where I set up the different, whatever. So it works. You should run your services alone. It means this is not only about your services running, but you should make sure that there is no other service or actually other container running. We have no support for this right now, and we are doing this like that. We know that we want to run the MySQL on some physical bare metal, and there are 16 CPUs, so we said here 16 CPUs, and we are sure that there will be no other container running, because we just gathered all the resources and that's it. End of the game. And we are actually happy about it right now, so we are not planning to just add some more fancy attributes. Why? So just keep in mind that you should do it. And yep.
Do you have some guide how to prepare the bare metal? Because if you just run it this way, there can be some YAML splitting caches and all these stuff which can interfere with the test. Because if you are running containers, there is still host always running, which can do plenty of stuff. So if you have some guidance how to set up the host for testing.
Well, actually, we have our state stack dedicated to our performance tests. So we know that there are only performance tests running.
Yeah, but I don't know if I need to set up it, for example, and I don't know what you are using for OS, if some Ubuntu CentOS or something like that. If you have some guide, how to tell the system to not do any stuff, because
Personally, I don't have, but actually I can ask my colleague Martin Siborski to come next Docker meetup, and he will tell you how to set up. Because
I think using the mesos framework, you're limited to actions or commands you can pass to the operating system. The mesos is just to receive the task and run the task, but you can't. I don't think there is a way to avoid other actions. But generally, if the machine is under maintenance, it should be under maintenance, and it should be maybe taken out of the mesos cluster and then added once it's done. And if your operation is doing it while you are testing the performance, you have to approach him, slap him, and next time you should have.
that was the reason I was asked about the guide. What to turn off, because some stuff
we should use some isolation. So, for example, if you have C groups, you can restrict the number of processors and the memory, and it's restricted just to the task. And in the next version, there's also limiting of network and limiting of disk. So if you have some like I/O really consuming, it would guarantee at least some resources for test running. So that should guarantee the same conditions for all tasks.
thank you.
Well, it's passed by two mesos.
Oh, okay.
So you pass CPU and memory, and mesos won't start the task unless it has at least this amount of dedications to your system. Should we say?
Well, last point is the how we revert data. I think that all who just using Docker, they know it's perfectly simple. You just stop the container and run it again. That's it. Docker just saved us a lot of time because our colleagues just been doing this on Oracle, like a snapshots or like everything the database back to the previous state, and it took like 7 hours to just finish the reversion of data. We are able to just stop and run Oracle in 40 seconds, so it's a bit faster. We just created the container with the Oracle and loaded all needed data in there, and just commit the container and with ready container and with all data in there, and we are able to just revel the database quickly, which is great on Docker. It's done automatically. So this part is done. There is a fourth chapter. It's more for your managers or people around you, because it's nice that you have run the test and you are playing all the time with it, but you need to just somehow just let them know what it means, how it behaves. So you need to collect the results from some JMeter or something, you need to store them somehow, and you need to visualize them. As you maybe know, there is no support in Yowie, because Yowie is just about the running Docker containers in some state. So we are doing it that we have next container which is responsible for this work. So when the JMeter finishes its work, it will start next container, which will take the results and put them to the Elastic. And we have Kibana in there, so Kibana will just show the results. I have demo of this thing also in here. These are the confidential data, so do not remember it. Here are some results. You maybe don't know what it means, but it's nice, and you know. And actually, it's live. So when you actually run the performance tests, this will be updated to the latest results. And we also using Yowie for the micro benchmarking using the OpenJDK framework, and you can see that we have all results here, and we can compare results between decays, between months, between builds, and we can see that everything is okay, is on the same level, and is done automatically. So. And actually also the Elastic is run in actually Docker 2, so Kibana is in Docker as well. So we have everything in Docker, and we are happy. So that's the latest or actually last point. Do you have any questions?
Comparing to your previous testings, like how much time you were saving per test?
Well, it depends on the test, but generally we can say that in previous it took like 7 hours to just finish some test, and with this we are able to just run it in 15 minutes. Mainly because of the actual database, which is started quickly. And moreover, because previously it was like a more the manual job, so people have to wait for the server to start, then run some commands. They made a mistake and they have to read it again, and it took time. So when it is done automatically and like this, it's much more faster.
So how many QAs had to lose the job because of it?
0, because we have the best one, best quiz. They was willing to change the job. And
you mentioned the collect.dd. You are using it for collecting the metrics from the containers or from the system or some other metrics.
For the collected, we actually collecting, let's say for the micro benchmark tests, we are collecting also the hardware specifications. because we need to, in the future, we will of course change the hardware we are running, so we need to collect all the hardware information, and then we can in Kibana make queries and compare the hardwares and just comparing the right things with the right things, not just apples and Python. So we are collecting. Yep.
How do you check state of the process? Is it just usual Linux process, or is it possible to make some?
Well, right now.